we continue our learning in policy modification. We already spent a video on the deductible. That is very, very important. Today we're going to learn policy limit. By its name, we already know what kind of modification it will be, right? So basically we set up a upper bound. So, that's why we usually use U to denote the policy limit, because U is the first letter of up bound. So it's very easy to understand. Let's say I have a policy, let's say home policy. It covers up to, let's put a number, let's say 30K. Up to 30K. So the maximum amount my insurance company will pay on my property is $30,000, no matter how big the claim is. So let's say there is a claim of size, let's say 40K. Okay, because I have such a policy limit, the insurance company, will pay 30K. The remaining 10K is bared by me. So I will have to come up with something to figure out the remaining $10,000. So that's the meaning of policy limit. It's also fairly common for auto insurance. If you get a used car, it's very likely that you will not have very high coverage. Maybe 100K is your policy limit. Sometimes, if you have a fancy, let's say Porsche, you want to go higher, let's say 300K for both you and the other party. But anyway, there is a policy limit on most short-term policies, especially like auto policy, property insurance, or flood insurance. Those usually have a limit. So if you have auto insurance, you can probably read your policy to know what your deductible is, what your limit is, and whether you have some comprehensive or not. Mathematically, we just need to introduce a notation. This is sometimes we call it a wedge, or the smaller one between A and B. This is easier or friendly notation, right? You take the minimum between two numbers, and this is slightly more convenient. You put a wedge. This means with policy limit, the left-hand side is the amount paid. Okay, so if the loss is less than the limit, well, let's put U if you want. Okay, put equality if you want. If the size of the claim, or if the size of the loss is less than the upper limit, the policy limit, the insurance company will pay everything. But if the size of the loss is bigger than the limit, they will only pay up to you. You will come up with the rest. Okay, that's why here we have a U. Okay, capital U stands for the upper limit. So defined above is called the limited loss variable. So this is the name for it. Again, it's somehow easy to understand, right? It's called limited. It's limited up to this number. So for insurance company, if they underwrite a policy with limit, they have a better idea on the cap, the maximum loss they will suffer. If they do not introduce a limit, the payment can theoretically go to infinity, or go to very, very big amount, right? I mean, for an auto policy, it could possibly result in a huge bodily injury, right? Let's say you drive a car and hit, let's say, a tourism bus. It could easily have 50, 60 people on board, right? If you run them over, it's going to cost several $1 million, right? And if you have a policy limit, well, the insurance company somehow, it's more comfortable, or somehow, they have better skills to manage a risk like this because they already know the cap, right? If you have 100K, they will only pay 100K, right? The rest, you will need to find a way to come up with. So that's why, when there is a policy limit, it's somehow good news to the insurance company because they know the maximum loss they will suffer. Okay, but it could mean a potentially huge financial liability to you because the loss can be very, very big, right? Can be enormous. So that's something when you buy insurance you need to think about. Okay, we have a fantastic formula, mathematical formula, that with this formula, we don't need to do much. We already did this part. This part we already did, right? Except in that case, it's deductible, not you. We have this nice result. You just need to do a little analysis, right? So x less than q, x range q is x. X minus q take positive is 0. So add them together, you get x, right? So you analyze x bigger than q is the same, right? So they will then this will give you, this one will give you q, the other one will give you x minus q. Again, it is equal to x. So this is identity, which is true for any value. Okay, with this in mind, so expected value of x equals the expected value of xu plus the expected value of x minus u take positive. Okay, we already know how to calculate this guy. We already know how to calculate this guy, right? This is from 0 to infinity, the survival function of x, right? This is the integral from u to infinity, right? Again, it's the survival function of x here. So, well, you know what this is, right? It's from 0 to u. So, you can easily figure out that this is from 0 to u, the survival function x dx. Okay, everything is nicely expressed in an integral form of the survival function of the original loss. That's why things is relatively easy to handle down here, right? And remember, when we define the loss elimination ratio is expectation of x minus the expectation of xl, right? In that case, it's x minus d positive. So we have this nice form. So it's essentially the idea of policy limit, right? So this is the if you look at this is somehow the policy limit, except now you apply the deductible amount as the limit, right? So it gives us a second idea of loss elimination ratio. So you have two different ways to compute loss elimination ratio. Next, we introduce, by the way, because all the computations can be converted to the deductible. That's why that there is a natural connection between deductible and the policy limit. By the way, somehow more interesting case. Let me get one page to tell you what's more interesting. I can have a deductible D and a limit at the same time. By the way, this is actually very common. So let's say limit is bigger than the deductible. So now, how many regions do I have? So right now, what do I need to know? So originally it's X. So first of all, I need to apply deductible. Okay, so this is the amount the insurance company may need to pay after applying the deductible. And then there's a limit. Right? The amount paid will not be bigger than this U. So when you analyze, write it in piecewise form, it's 0 if the original loss is less than the deductible, Okay, it will be X minus D if the size of the loss is bigger than the deductible, but less than or equal to D plus U. Okay, and finally, it will be U if X is bigger than D plus U. Okay, be careful on the terminology of this upper limit. So in this particular example, the upper limit is applied to the deductible. So you apply the deductible first, and then you apply the limit. So this limit will be the absolute amount that the insurance company will possibly need to pay. So this is the max amount that the insurance company may need to pay. Sometimes this U is directly applied on X. So let's say I have a policy that will cover up to, let's say, 10,000 loss. Okay, so per loss or per deductible, there's a different, right? So in the other case, this will be applied in this way. Because this limit is directly applied to loss. So this policy will cover the loss up to, let's say, cover the loss up to, let's say, 100K. Okay, so here is the policy will pay up to 100K. So sense the difference between those two scenarios. Here is pay up to U. So let's say U is 100K. Here is cover the loss up to 100K. So if there's no deductible, if deductible is 0, okay, those two are the same. But if there's a deductible, the first one will pay up to U. The second one will pay up to U minus D. So that is the difference. So be careful on the context. Okay. The third modification is coinsurance. Coinsurance is actually very, very easy. It's too easy. You can see from here. All right. So basically, it's the two parties, the insured and the insurer, will share the loss by proportion. Let's say I have a co-insurance for my healthcare. Let's say I pay 10%. My insurance company pays the remaining 90%. So it's always the case, right? So that's why here it's very easy to analyze the PDF function. I believe all of you know how to do, right? So I always ask you to do this. This is the CDF. Okay, by definition, is XC less than X. So this will be small c times capital X less than small x. So it will be capital X less than X divided by C. So now I can write it in integral form. So now I differentiate on both sides. I get the PDF for my modified XC. On the right-hand side, it will be 1 over C times fx plug in will be x over c. So bingo, I just proved 2.97. Okay. This is very easy, right? Okay, so this is the nice thing we have. By the way, this is what I meant earlier on. The limit is actually applied to the ground up loss. So it is applied to the ground up loss. Or you can think of it this way. So when you have both deductible and the policy limit, you have two scenarios to think about them. First is you apply deductible first, and then you apply policy limit, okay? Or you can apply at the same time, right? So this is, you can apply at the same time. So the loss is capped, and the loss is also bounded below. So here they actually apply at the same time. So the policy limit U is applied to the ground-up loss. So I will be very, very specific when I ask you this type of question, whether it's applied to you or whether U is the absolute amount the policy will pay, okay? So in this particular dot point, they have 3 modifications: deductible, policy limit, and co-insurance. So co-insurance is the easiest way to understand. By the way, here they define C to be the proportion paid by the insurance company. So 1 minus C will be the part paid by the customers or the policyholders. So that's why, you know, it will be C times whatever is remained, okay? This is the part we have, okay? You can easily separate them into 3 different scenarios, right? So as we can see, if this U is directly applied to X, you discuss U and D as 2 separation points. If it is applied after the limit, if it's applied after the deductible, the 2 points will be D and D plus U. So that's another way you can decipher the difference. Well, this you know already, right? So this when you have this type of form, you need to apply the integral twice, right? So in the analysis, you don't need to plug in. Do not plug in the number first. Do a general integral. So think this as any argument, and then you just need to plug in 2 values for that argument. So that will save your computation time. Here we have an example. I think it still comes from the previous 2.10. X is exponential. Exponential is very, very easy, right? Because we know for, let's say, let's put X. Right, so this is general, right? So if you apply deductible, it's E of negative D. If you apply limit, it will be E of negative U. So you know it's very simple for the exponential, and you can easily get the difference. For the log normal, we already know the general formula, right? All you need to do is to replace D there by U here. So you can see everything still holds. I will leave the detailed computation to you. I already did the mathematical proof in a previous video, so you can easily follow the computation here. The last one we introduced down here will be inflation. So inflation, it has some idea, you know, similar to co-insurance, but it's not exactly the same. Okay, co-insurance, the proportion is less than 1. So let's say insurance company takes care of 80%. So the policyholders take care of the rest, the 20%. Here, when we consider inflation, the inflation is applied on the size of loss. Okay, let's say there are several reasons, you know, you could think of why it is important to consider the inflation. For instance, the money is losing value because of the inflation, and because of that, let's say if we consider auto insurance, you need to take care of the inflation because let's say the wages of people working at the garages, you know, they increase from year to year. Let's say the labor cost, you know, what I just mentioned is the labor cost, they tend to increase, right? And the parts, the cost of manufacturing some parts tend to increase, and the cost of renting of getting the physical, you know, infrastructure is going up as well, which means in general fixing a car is becoming more and more expensive, right? So the cost of fixing cars, they increase. That is the reason why you that is one of the reasons why I just give you an example to motivate why it's important to consider inflation. The same for healthcare, right? Healthcare is only getting more and more expensive, right? 20 years ago, I mean, you don't need to pay, let's say, $20 for cold medicine, right? It's probably just $2. So as you can see, the cost behind claims is constantly increasing, right? By various reasons. That's why we want to apply the information factor to adjust the size of the claim. It's getting bigger. So you apply a positive factor down here. So it grows from X to 1 plus R times X. We apply a simple multiplier. That is the easiest way you can handle the increasing relation, right? You apply a factor which is greater than 1. So it goes up. So that's a straightforward idea behind this modeling. And then what we do is, so by the way, this x tilde is 1 plus r times x, okay? The deductible, well, let's say we apply the same deductible, okay? So what you have is actually a modified deductible. So if the size of the claim goes up and the amount of deductible remains the same, effectively, that means you actually have a lower deductible, right? So let's say that's the same concept of money, right? So let's say right now you pay $100 to get your car serviced once, okay? In 10 years, let's say everybody's salary goes up by I don't know 20%. Okay, let's be optimistic. You still pay $100 to fix your car. In that case, the cost of getting your car serviced is actually going down, right? Although you pay the same amount of money. For the same reason, if X is proportionally increasing, but your deductible remains the same, that means effectively, the size of the deductible is actually going down. And the effective one is the original one divided by 1 plus R. The analysis itself is of course, mathematically, it's very easy. You just factor out a positive constant outside. It can be taken out from everything. So you have this. So when we have information, pretty much everything, the mathematical part will be the same. The deductible changes as well in this case, right? So for the same reason, once you have analyzed the expectation for the payment in a loss event, you can do something similar for the payment in a payment event, right? So that part it's easy to do. So basically, you can see basically what you do is you use d over 1 minus r to replace d. So that's basically what you do. I think I will end here. The next one it's somehow a tough one to study. The actually is not even in the slides, so I will simply write it. Is how modification affects the claim frequency. That is a very difficult topic. I will use a separate video to discuss that.